Hello everyone and welcome to today's video. Today we will be preparing for this first periodic of computer science for term 2. And by the end of this video, I will cover two questions that might be similar to pseudocode questions you may encounter in the written, like if you were given to write an algorithm. So let's go ahead and start with the quizzes. Which of the following ensures that the field is not left empty? This is presence check, which is basically in the name. Presence checking if it's there, if it's not left empty. Study the algorithm below. It's supposed to input 4 numbers, add them together and display their sum. The program does not work as it should. So basically this question is implying that you need to find the error. So first, what you should do is look for anything faulty in this code. Counter is equal to 0, that's correct. Usually counter statements start at 0. There are some exceptional cases where it may start at 1, but we don't have this case, so you don't have to worry about it. Sum, it should always be equal to 0, so that's fine. While counters less than 3 do. Here is the problem. It's asking to input 4 numbers. However, we're doing counters less than 3. So this is where our error is being produced, so therefore, this is our correct answer. Consider the following code. The code above is supposed to input positive numbers only and then output their average. When a 0 is entered, the process should stop. To make the code work as intended, what should replace the missing statement on line number 9? So what you can do with this question, instead of reading this entire code, you may just quickly understand what it's doing. Or quickly find things. So as in our case here, counter is equal to 0, but it's also used here. And here's the thing, if you know in math, dividing a number by 0 yields an undefined number. So there should be something that changes counter here. Since there's nothing here that changes counter, we use the counter equals counter plus 1, because that's how you use the counting statement. A piece of pseudocode was written to calculate the sum of 5 numbers entered and then output their sum. How many errors are found in the pseudocode? So let's start from the beginning. Sum equals 0, like I said, always should be equal to 0, so that's fine. For count equals to 1 to 10, it's asking for 5 numbers here. If you do what's being done here, you'll input 10 numbers, which is not what we want. Input number, that's fine. Number equals sum. This is not how it's done. It should be sum equals sum plus number. Count equals count plus 1, that seems fine. Then you reach here. If you keep this in, this will mean that the program will increment twice. We don't want it to increment twice, so you should remove the count equals count plus 1. Plus, the for statement has a built-in counter, built-in incrementer, so you don't need this. So now we are at 3 errors so far. Print count. We're not supposed to be printing count right now. We're supposed to print the output of their sum. Or we're supposed to print their sum. So here should be print sum. Therefore, there are 4 errors in the pseudocode. For students with ages ranging from 5 to 17, which of the following ages can be considered as extreme data? Extreme data is basically the value of the upper or lower bound, so either choose 5 or 17. Here in our case, it's 17. What can be used to represent an algorithm? Flowcharts, structure, diagrams, and pseudocode. Simple. Which of the following connects one point of a sequence to another? Here, this might confuse you, but what it's trying to say is which one of these shapes connects a very far point to another very far point. Here you use the connector shape. Consider the following algorithm. In which lines can we see assignment? So assignment is basically this arrow right here. It assigns something to a variable. So in which lines can we see this? Well, you can see it's in lines number 1, 2, 3, 4. So just select all of those. The component parts of a problem are, it always goes inputs, storage and processes, and outputs. You have to memorize it. What is the following an example of? So here you can see pseudocode that calculates the average of 2 scores. So it's pseudocode. That's it. Which of the following is a way of representing algorithms using everyday English, making it a convenient and user-friendly way to describe algorithms? The keyword here is everyday English, because flowchart uses shapes and symbols, meanwhile structured diagrams basically use like symbols. So pseudocode is the only viable answer. Which of the following holds a value that can change within the algorithm? Once you see holds as a value, there are only two real options: constants and variables. Constants, however, don't change throughout the algorithm. Their value is held constant, like in the name. So variable is the correct option. We use blank to check if the data falls within the specified range. Keyword range, go for range check. Which of the following can be used at the beginning and end of a flowchart? We're looking for the terminator shape, which is represented by a rectangle with rounded edges, or vertices. Which of the following can be used for reading data or writing information in the program? We're looking for the input or output shape, which is the trapezoid here, or parallelogram. Which of the following can be used for arithmetic operations? We're looking for the process shape, which is a rectangle, a regular rectangle, not to be confused by the subroutine shape or the terminator shape. Which of the following can be used when a decision has to be made in the program? Here it's the decision shape, which is this, the rhombus. Which comparison operator can be found in the following algorithm? So here you need to look here. Here you can see n is greater than 100. So you can just choose the greater than. What is meant by dry running an algorithm? Basically what it is there's an algorithm and you just like manually run through it to see if there's any errors and like also to see what it does. So here. Which of the following are the stages of the software development lifecycle? There are 4 stages, which is and first you analyze the problem, then you design a algorithm, like a test algorithm to prepare for coding, which is the next step, and then you test to see if this code works as intended. Which of the following are not part of the pseudocode or the algorithm, instead they may explain the instruction or variable? Here it's comments. I'm not sure if you guys took it, but comments basically are little things that let you know what this certain instruction or variable stores. In pseudocode, if you want to write a comment, you may usually use a hashtag symbol or the pound symbol. So let's say here, you have this line of code and you want to explain to the person who's reading this line of code what it's doing, let's say. So what you do is write the pound symbol and say, this makes a constant named upper variable or named upper limit and sets it to 100. This since this is like a simple line, you won't really need to do comments, but if your program is more complicated, or you might have to use the comment occasionally to like let the user know or let the reader know what's doing. Which of the following holds a value that does not change within the algorithm? Like I said in the previous question, it's constant. It holds a value that does not change. Which of the following is an error in the calculations or the program logic that results in an incorrect result? The keyword here is program logic, so you go for logic error. There's another error you might deal with is the syntax error, and this is usually on the programmer's side, unlike the logic error, which was on the computer side or the program side. Syntax error is basically like, let's say you're writing Python and you do print 3. In this case, it won't work because the P is capital. It should be small p. There are other examples of syntax errors, but this is the simplest one. Consider the following program flowchart. What's the output of the following input? Number equals 4 and temp equals 23, 1, 15, negative 3. When dealing with these types of questions, I suggest you write down the variables and once you're done using a variable, you cross it out. So let's just start here. Start input number So what you do is take whatever's in number, and I'd suggest like writing it next to it. So you remember, or you can say number equals 4. And then you go to the next step. Count is equal to 1. So total is equal to 0 and negative is equal to 0. Here you have to keep this in mind. Or like you can just refer back to here if any of these variables are mentioned. Input temp. So what you do here now is you take 23 and write it next to here. And you can cross out 23 here. Is temp greater than or equal to 20? 23 is greater than or equal to 20, so you can move here since it says yes. Total equals total plus temp. So now total will have a value of 23. Let me just write it here. So total now has 23. It will move here until count is equal to until here. Count is equal to count plus 1. So initially count was 0, count was 1. Now it will be changed to count equals 1. Or 2, I mean. Because 1 plus 1 is 2. And then we check if count is less than or equal to the number. 2 is less than 4, so we can continue on. Then you input the next thing of temp. So we get rid of the 23 and replace it with 1. Is 1 greater than or equal to 20? No, so you can move on to here. Is temp less than or equal to 0? 1 is greater than 0, so you can just ignore this. And you can move on to count equals count plus 1. This changes it to 3 now. Is 3 less than or equal to 4? Yeah, so you can continue on. Input temp. Now you're inputting the number 15. 15 is not greater than or equal to 20, so you can move on to here. Temp is also 15 is also not less than or equal to 0, so you can move on. Count now has a value of 4. This count then it checks if then you input the final value, negative 3. So now temperature has negative 3. Temp is greater than or equal to 20. This is false because negative 3 is not greater than or equal to 20. Temp is less than or equal to 0. This is true because negative 3 is indeed less than 0. So you go here, add increments negative by 1. So neg now has a value of 1. Then you increment count by 1. So now it has a value of 5. 5 is less than or equal to 4. No. So then you move down to here. My bad. Okay, here we go. So now you move down to here to output total and negative. So you just look at whatever total was, and you look at whatever negative one, and then you just print them together. So let me just get rid of all this. So therefore you choose 23 and 1. The pseudocode below asks the user to enter as many numbers as he or she wants. The iteration stops when 0 is entered. The number of entered values is then displayed to the user. Which of the following is a correct replacement for a missing statement so that the pseudocode works as intended? So we're making use of a count variable here, but it's never changed. So like I said, you need, or like similar to that previous question, you have to use this to change it. The pseudocode below asks the user to enter as many numbers as he or she wants. The iteration stops when 0 is entered. Print and which of the following is a correct replacement for missing conditions so that the pseudocode works as intended? So we want this program to continue on if it's not equal to 0, which is this. While number is not equal to 0, you may continue on, otherwise it will stop the loop. The array marks declared below holds the marks of class of 30 students. What is the purpose of the following pseudocode? When these types of questions come up, you have to analyze the code. So first result is set to marks 1. So here you can see that result gets the first variable of array, or first item of array of the mark array. Then for index, 2 to length marks. So basically, it's gonna check everything else, everything other than the first item. Then if marks is less than the result. So it's saying the current value, the current item is less than the first, or whatever is in results, because this may change in the program. So just because of this, we can realize this might have to do some. Because of this line of code, we may realize that this is trying to find the slowest value in the array marks. So we can choose this one. But let's continue on. Results gets marked index. So if this holds true, meaning that if this item is less than the result, then result gets whatever is here. And then continues on until it checks all items in the list. The array marks declared below holds the marks of class of 30 students. What is the purpose of the following pseudocode? So like I said, analyze. Result is set to 0 for index 1 to length marks. If marks index is greater than or equal to 9, then result is incremented by 1. So here it's checking for all values in the mark array, and it checks if any of the items in this array is greater than or equal to 90. So it counts and displays the number of values in marks that are 90 and above. The array marks declared below holds the marks of a class of 5 students. Suppose the marks contain the following values: 92, 83, 65, 78, and 96. What would be the content of marks after applying the following pseudocode statements? Here you can realize this is a variable switching algorithm. You can notice this because of the use of a temporary variable, and in addition, there's a use you can like make a little shape. So marks 1 here and marks 5 here. Usually whenever you can make this little shape, then that means that this is a switching statement. So what it's saying here is that whatever's in the first item and the fifth item are being switched. So then that becomes 96, 83, 65, 78, and 92. The pseudocode statement below is an example of a counting statement, because whenever it's incremented by 1, it's usually counting statement. The pseudocode statement below is an example of totaling, because when there's a variable here and you're adding that variable to another variable, that's a totaling statement. What's the purpose of the pseudocode given below? Repeat, output, enter a number, input n, until n is greater than 0. Repeat, output, enter number, input number, count gets count plus 1, total gets total plus num, until count is equal to n, and then it outputs the total. So it's going to display their sum, or it's going to display the sum of something. So what we should pay attention to is this part. So it asks the user to input a number and keeps asking this if the number is less than 0 or is 0. So there's a use of n, which is found here, but not in anywhere else. You can get rid of all of these, which should leave you with the final answer, this. But let us continue on with the pseudocode. Repeat, output, enter number, input num, and then it does all of this. And yeah, and then inputs a number, it increments the counts, and it totals that number to a variable named total, and checks if the count is equal to the number the user inputs here. So basically, it's asked the user to enter n numbers, then calculates and displays their sum. Which of the following examples of selection statements? Selection statements are basically like Selection statements are basically like conditional statements. So in our case, case and case, if then and if else and if. While and while, repeat, until, and for next are examples of repetition statements, because they all repeat for a certain amount. The for next is a loop that does the statements for a predefined number of times, because if you remember, you do for I in range of 1 to 50, let's say. It goes for a predefined number of times. You declare how many times this loop will go. Which of the following is a loop that iterates at least once? What it's saying here is no matter what, this loop will will iterate at least once. We can get rid of the for when it's asking for these types of questions, and you can also get rid of anything that is not an iteration statement. So we're left with these two. If you recall, while is a preconditional loop and repeat is a post-conditional loop. So here we have two programs. One uses the while and one uses the repeat. So let's say, actually no, hold on. So here we have two programs. One uses a while loop and one uses a repeat loop. Let's say A is equal to false. If A is equal to false, this whole thing is skipped and moves on to whatever's after it. In the repeat case, if A is false, it just does the statements first, and then it checks. And so therefore, a repeat is a loop that iterates at least once. Okay, so let us start with the second quiz. And the while and while is a blank. So like we saw in this example, we saw that if A was false, it wouldn't iterate. So here, it's a loop that may not iterate. So the following is a loop that does the statements first, then checks the condition. So let's just pull up this example again. Here it checked this condition first, and then it did the statements. Here it does the statement first, then the conditions. So you can see that the repeat loop. The while and while is a blank. So let us pull up the while. Here it checks the condition first, then does the statements. So the loop that checks the condition first, then it does the statements. The pseudocode must print the message allow access only when the pin is 789 and access denied otherwise. So first, analyze the statement, see if there's or analyze the condition, see if there's anything wrong with it. Here, pin is equal to 789. That makes sense. Pin equals 789, but there's no then, so you can get rid of this option. Pin is equal to 789, then that makes sense. Pin is not equal to 789, but it outputs allow access, so you can ignore this. And password is equal to 789, so you can also ignore this. So we're left with this one and this one. Output allow access, input allow access. You're supposed to be printing it, outputting it. The case and case is an example of decision statement that deals with many cases. The if and if is an example that deals with one case. With this question, you can just look in specific areas of this line to get your answer. So first, we'd want the type of items being stored in this array, which is real. So you can get rid of this. So this is real. Then we want the name of this array, which is found here. So you can get rid of anything that does not have the proper name. Then we want the size. There's two different conditions you may have to. There's two conditions to this. If it starts with 1, then you have to do, let's say, 15 minus 1, all that plus 1 to get the size. But let's say it's 0 to 15, you just do 15 minus 0, which is 15. So get rid of anything that doesn't have size 15. Then we want the first index. Here it names the first index as 1. So you can get rid of this, leaving you with this answer. Which of the following two code statements refers to a loop structure? Here is a condition statement. Here is an input statement. Here's what we're looking for. This is a loop structure. Here's assignment. Here's output. The pseudocode below represents an example of. First, you need to read through. Print enter your mark, input mark, and then if mark is greater than or equal to 60, then print you passed, else print you failed. Here there's a conditional statement here, so the answer must be a conditional. But there's more than one. You can also say decision or selection. Which of the following statements display the value of a number? That's the point of the output statement. It outputs the value of a number, it displays it. Which of the following pseudocode statements declares a constant called min price that holds the value 35? So first it must be constant. So you can get rid of all of these, basically, leaving you with this. Which of the following pseudocode statements declares a string variable called school and initializes it to Sabis? So it's declaring a variable as string. So get rid of this because there's no declaration. Here it declares school as string, so you could keep this. Also here it declares it as a real, and here it declares it as an integer. However, we also need to initialize it to Sabis. So you can also get rid of this one because it's not initializing it to anything. So it leaves you with this one. A constant or a variable that holds a sequence of characters refers to the string data type. Like it's a string of characters. A number with a fractional part that can be positive or negative refers to the real. So real is basically a decimal. It can be positive, negative, or anything. All that, like the only unique thing about it is it has to be a decimal. Match each data type with its proper description. Abnormal data is the data that falls outside the range of acceptable data, meaning it shouldn't accept this data. Extreme data is the data at the limits of acceptability. So let's say with a previous question we had 5 to 17. If it's at the limits of acceptability, like 5 and 17 are at the limits of acceptability. Boundary data is data that falls at each end of a range of normal data. So let's go back to our example of 5 to 17. The upper boundary would be 17 and 18, and the lower boundary would be 4 and 5. Leaving us with normal data is the data that the program is designed to handle. So we're given this pseudocode algorithm and we're trying to find the first line that contains a loop, which is line number 5, because it's the first line that has the repeat statement. It has a repeat statement, so line number 5. Consider the following algorithm. Give the first line number containing a totaling statement. So totaling, you're looking for a variable gets the same variable plus another variable, which you can find here. Total weight gets total weight plus weight. So it's line number 8. Click on the shade that shows the direction of the instructions between the flowchart shapes, which is this one because the arrow. Click on the shade that shows the direction of the instructions between the flowchart shapes. Here it's the arrow because the arrow shows you how the flowchart flows, or how it moves from one statement to another. In computing, and something is a sequence of steps that describes the solution to a given problem. That's an algorithm. This is basic, really. Match the following component parts with their respective description. Inputs is the values entered into the system to solve the problem. Storage is data that needs to be saved on any file. Processes is tasks done on input data and or saved data. And outputs is information that is produced and displayed to the user. So let's say here, why would we usually want to indent this? We usually indent statements to show that these statements belong to this. So let's say if we had another statement here, like let's say output X, we wouldn't want this statement to be confused with anything here. So to indicate that they are contained in the statement preceding it. Consider the following algorithm. What is the output of the algorithm that the user enters the number 3? So let's say at the input n is equal to the user inputs the number 3. So meaning n now is equal to 3. So first it checks if n is less than 3, less than 0, I mean. 3 is not less than 0, so it does not output negative, it will output positive because it's else. So it should output positive. And by the way, if it ever gives you this type of question and you need to type it in, make sure it's exactly as it's in the string here. It has to be the same capital, it has to be the same full stops if there is any full stops. It has to be an exact copy of whatever's here. Which validation check checks if the data has required length? Keyword here, length check. For students with grades ranging from 0 to 20, which of the following grades can be considered as abnormal data? Abnormal data is basically anything that does not apply to this range or is not inside this range. 20 is inside this range, but it's considered extreme. 10 is inside this range, so it's normal. 0 is inside this range too, but it's considered extreme once again. 19 is inside this, so it's fine. Negative 5 is the only one that is not inside this range, so this is why we call negative 5 abnormal data. Checksum is used only to check if any transmission errors have occurred. So visual verification, basically, a data entry, someone inputting data, they input the data into the computer and they have a piece of paper with that same exact data. They then check if the data on the screen is the same as the data on the paper. If it is, then it's validated. Otherwise, then they have to retype the data. Double entry, however, is used when the same data is entered twice, as is in the name, double entry, 2 times. What is the output of the following flowchart if grade is equal to 9? So first, you start at the start and then you go down. Output, what is your grade? So that's fine, that's normal. Input, grade. So grade gets the number 9. Grade is greater than or equal to 10. 9 is not greater than or equal to 10, so we go down to the no arrow. So it should output you failed. And like I said, make sure it's exactly verbatim to what is stored in the string. Using flowchart, which of the following shape is used for a named subroutine or model that is defined somewhere else? This. Alright, let me go back. This is like the subroutine or module shape. Choose the answer that correctly completes the following sentence. Something are used to ensure that data is valid and is thus acceptable for processing. Keyword here, valid. It should be data validation or verification, or validation checks, I mean. Choose the answers that correctly complete the following sentence. Something means to ensure that data has been copied correctly from one medium to another. It involves checking that whatever has been entered by the user is exactly what the user meant to enter. Here is verification. You're verifying if it was input correctly. The below figure shows a structured diagram. Because in structured diagrams, it always has this shape. Choose the answer that completes the following sentence correctly. Examine the below flowchart. Given that x is equal to 25 and y equals 5, then total equals what when the program stops? So first, you go at the start and then move down to total equals total. So keep these in mind. Total is first equal to 0 and I is equal to 0. Let me change that because that looks like a 6. And total is also 0. Input x and y. X has 25 and y equals to 5. So it moves down here. I is less than y. So 0 is less than 5. This is true, so it goes to here. Total equals total plus x. So 0 plus whatever is in x, which is 25. That gets 25. So now total, or let me go here. Total now has 25. And I is incremented by 1. So I here becomes 1. And then it goes back to here. I is less than y, which is true. Alright, let me go here. So we can replace the 0 here with 1, which holds true. So now we're gonna add to whatever's in 25, or whatever's in total, to 25. So 25 plus 25, we get 50. So total now is equal to 50, and I should be equal to 2. Then it does this, it keeps looping until I is not less than y. So then 2 is less than 5, that's true. So we take whatever's in total, add that to 25. Or not 25, my bad, 50. And you get 75. So total now has a value of 75, and I gets 3. Then checks if 3 is less than 5, which is true. So now we're doing 75 plus 25. You get 100. So total now equals to 100. I now gets 4. Then it checks if I is less than 5, which is 4 less than 5, which is true. So you do 100 plus 25, which gives you 125. So total now has 125. I has 5, which finally makes I is less than y false, because 5 is not less than 5. So we go down to no and print total. So total gets 125. Flowchart shape. This is the terminator shape. This is the decision shape. This is the conductor shape. This is the process shape. This is the input. And this is the flow arrow. You need to memorize the shapes and what they do. If you don't understand, you can refer to the book or go to the internet for a better explanation if the book does not help. A program is designed to accept a student grade mark out of 100. For each of the following test data, mention that they are normal, extreme, or abnormal test data. Use the letters N, E, and A to indicate the test type of the data types below. 35. It's between 0 and 100 normally, so this should be a normal. 78. It fits snugly between the range of 0 to 100, so this should also be normal. 100 is at the limits of acceptability, so this is extreme data. 102, that's greater than 100, so it falls outside of the range. Therefore, it should be abnormal data. B isn't a number, so it's instantly abnormal data. 21, it fits snugly between the range of 100 and 0, so this is normal data. 0 is the lowest extremity of the range, so therefore this is extreme data once again. And finally, negative 20 is abnormal data because it falls outside of the range. A data structure that contains numerous data items of the same data type is known as an array, or an list, but it puts array just in case. Match each of the following pseudocode operators with what it does. And this sign is usually used for exponentiation or power of, you can say. This sign is always used for division. This sign is used for multiplication. This is used for assignment. This means not equal to. This means less than or equal to. And this is modulo. And modulo, what it does, it returns the remainder of division. So let's say you have 5 modulo 3. So you run 5 modulo 3 returns 2. You can check that at home yourself by dividing 5 by 3 and see what you get as a remainder. Okay, so as you can see here, I've prepared two pseudocode questions, one much simpler than the other. Let's start with the simpler one. First, you must accept three numbers as input from the user, then calculate their average, then display the average. So since there's a use of a variable here, what you can do is input is like write average gets 0. Normally you're supposed to write an arrow to indicate, oh, it's assignments. Or actually, let me just get the ASCII character. So here, average is assigned to 0. Let me zoom in so it's easier to see. So average gets 0. Then you move on to the next step, calculate accepting the three numbers as input from the user. So input, three variables, let's name them num1, num2, and num3. And what I suggest doing, like let the user know they're inputting numbers, before the input statements write output, input three numbers. What's next? What you should do next is calculate the average. So now we get average again and assign it to num1 plus num2 plus num3. And what I'd suggest doing is putting these all in parentheses to indicate that you should add them up first, then divide them by 3. What this does is calculates the average and then assigns it to the variable we called average. And then we want to display the average. So what to do, make a new statement or make a new line, output the average of the three numbers entered is, and then you write average, the variable, to indicate that to indicate that. What you can do is go to pseudocode pro and like check if this works. But there might be some cases where that's not doable because you might have to make up a function, like in our next question. Write a pseudocode algorithm to accept a password from the user, check if the password is at least 8 characters long, contains at least one uppercase letter and one lowercase letter, and contains at least one number. Display a message indicating whether the password is valid or not. So first, what you should do is declare the variable password. So let's do that first. Declare password string. And what I suggest doing is, if you're doing this in a written part, leave some space for the declaration of variables, because let's say you're writing the program and then you realize, oh hey, I need to declare another variable. You'll have space instead of like cramming it. So like, let me just visualize that. Then the user has to input a password. So input, output. Let me do output first because that's what you should do. Input a password. And then input password here. Then here's when we start doing our checks. First check we should do is check if the length of the password is at least 8 characters long. So there's definitely an if statement here. So let me just prepare that as if statement. So we need to first check if the length of password is at least 8 characters long. So what we do is using the length function, find the length of password and check if it's greater than or equal to 8. Then what we do is we go into here and let's say now we need to make a new variable called let's say length state. So declare length state boolean and initialize it as false. Yeah, length state gets false. So then this changes it to length state true. This is our first thing done, so we can get rid of this now. Now we need to check if it contains at least one uppercase letter and one lowercase letter. So we can actually combine these two. For let's say I, that's what you usually use as the index. In range of 1 or 0, because that's how you should start indexing, to the length of password, do the following and then next I. So we want to check if there's at least one uppercase letter and one lowercase letter. What we may do, since we don't have a dedicated function for uppercase at finding if a letter is uppercase or lowercase, what you may do is make up something. So let's say in my case, I want to do it in an if statement. So if password I equals lowercase, then what it does is sets lowercase state gets true. And here you should also declare lowercase state. And also let's make one for uppercase. And let us do the same thing for lowercase. Or uppercase, I mean. And I suggest like leaving spaces between each condition to make sure it's neat and tidy, so it can be understood by whoever is grading your paper. Then we do end if. Then finally we check if it has at least one number. So if password I or password at index I, we should also use the type function, which checks if it's an integer or yeah. So type password at this index equals integer. Then also yeah, just to stay safe, I'd suggest changing this to all capital. Also this to all capital. Then we need one more state for the number. So let me do declare number state is boolean. Then number state gets false. Then number state gets true. then and if. Now, there's definitely more efficient ways you can go about doing this, but this is like using base knowledge or knowledge that we're given about pseudocode. Then what we finally do is display a message indicating whether the password is valid or not. So there's definitely use of an if statement here. So we need to check if everything here was true. So if length state equals true and uppercase state equals true and lowercase state equals true, and finally number state equals true, then what you can do is output. We want to see if it's valid. Password is valid, else output invalid password. And this should be your answer for this question. Like I said, this might be a bit inefficient, but this is all you can really do with our knowledge of pseudocode. And okay, that should be it. If you need any help, please go in the comments, I might answer. And yeah, that's it. Have a nice day.